Nice. So hey everybody, my name is Jeremy Woods, and this is Daniel Santiago. And today we're talking about navigating the future with Jetpack Navigation 3 Enterprise Edition. Some quick intros about who we are. We work for Google. We are the Android X architecture team. We create building blocks for your app with things like room, lifecycle, view models, and then things that touch UI components like activity fragments and Jetpack Navigation. And recently at I/O, we released Navigation 3. And today we're going to talk about using Navigation 3 in a large application, and specifically we'll be using dependency injection. So what is Navigation 3? Everybody clap, so you might know this already. It's our new approach for navigation and compose. It focuses on making integrations easier. So historically, with the old navigation, it was really hard to put your own components into it. And now with Navigation 3, we think we're on the way to solving that. And then it's compose specific. So none of the old view and fragment considerations are made here. It's all compose. Everything that compose gives you advantage of, Navigation 3 looks to take advantage of that. So what are the goals of Navigation 3? So embrace compose state. So we want to be completely declarative. You decide what your state is. You pass it to Navigation 3, and then we just output that UI. And then we want to get out of your way. So like I said, the old navigation was a black box, and you had to use components there. Navigation 3 is built with a bunch of different building blocks. And if you decide you don't like ours, you put your own in, and it should still work the same. And on that same wave, we kind of provided a bunch of recipes. So we're opinionating our recipes and not in our APIs. So you can use our APIs without getting our opinions there. You can make the mental model your own. So that was a really quick overview of like what the idea behind Navigation 3 is. There's a video on YouTube if you want to like get some more background, but I'm going to try to jump into some code as quick as we can here. And we're going to do that by coding an app today called Cool Computer Cats. So this app is very simple. There's some computer science quotes, and then there's cat pictures associated with them. It has a feed screen to show all the different posts you can go into, and then it has a post screen. So that's the app we'll try to create today. And in order to do that, I'm going to go through some Nav3 APIs really quick. So we have the nav display, and this is your entry point into navigation. And these are all the parameters that a nav display can take. But today, we're going to keep it very simple. We're only going to talk about 3. We're going to talk about the modifier, the backstack, and the entry provider. On the backstack, very quickly, this is your compose state. So earlier, when I was talking about we want to be declarative and we want to just take in your state, the backstack is that state that we take in. You pass in Navigation 3, you get UI. But what is the T in the backstack? What items are you actually putting in the backstack? And you can put anything you want in this backstack. It's your key, you own it. You decide what those keys are. And we're very sticking strongly to that. We have recommendations though. So we recommend that you use savable objects. Remember, you own this backstack, so you're responsible for making sure that it's saved. And we also recommend that your keys be unique. The other parameter that we're talking about is the entry provider. This links your keys to your content, and it does so via a nav entry, which is the object that stores both of those things together. And Navigation 3 offers a DSL that we'll use. Like the entry provider is actually just a lambda that returns a nav entry, but we'll use a nice DSL today to make this easier. So an example of the entry provider DSL implementation, if you're passing this into nav display, you just, in the entry provider parameter, declare your DSL, and then it provides an easy entry where you can use a reified key, and you can just add your composable content there, and that's it. And this is an example of the nav entry class. We won't get too deep into this, but this is what the entry provider actually returns. And this is a quick flow diagram overview of how this all works together, because that was extremely fast. So you have a backstack, and then you do navigation events to that backstack. Nav display knows about that backstack. It gets a key that you have given to your backstack. It passes it to the entry provider. The entry provider gives you a nav entry back, and then nav display can display the content from that nav entry. And now we'll get into some live coding and see how this goes. All right, so we have a really simple app. This has a scaffold and some text. Let's make sure this runs. Okay, great. So we have hello world. Let's remove this as quickly as we can. Come on, slide Danny's computer. All right, so not getting off to a good start, but we'll get there. We'll add a nav display since this is our entry point, and we'll go ahead and define our backstack, our modifier, and our entry provider. this modifier so scaffold doesn't yell at us. We'll just go ahead and put the padding in. I'm sure everybody has experienced that. Oh, did it go? Okay, and then we need to find our backstack. So what would our backstack be? We can keep it very simple. Backstack, we'll remember it so Compose knows that we care about this item. And then we'll do a mutable state list of. So what items should be in our backstack? Remember, we wanted to find the feed screen and the profile screen. So I'll do the feed screen here. So our designer is so good. They knew Compose and they wrote this for us. They wrote us a feed screen and it passes a cat parameter to the post. So that's already done for us. So the only thing we'll do here is write our key. It's a serializable object that is a feed. And we'll mark it with this nav key interface, which you don't actually have to do, but it's part of the it's part of Navigation 3, so you can mark interfaces that are specifically keys. And we'll go back to our main activity. We'll make this mutable list of nav key, and then we'll give it feed, and we'll pass in our backstack. Make sure we import that so we don't have any mistakes. And then now we'll define our entry provider here, and it's just like I just showed previously. We have an entry provider DSL is there, and then we'll define this entry as feed, and we'll get our feed screen, and we need to pass the backstack so it knows that it can go to the post screen, and then I'll go ahead and define our post screen as well. And this one is fun because it takes a backstack as well as a post object, and that key is provided to us by the entry DSL. And that's it. Let's see if we actually made it through this. Nice. So we have a very simple app. We have the feed screen, and we can go. There's a show. Let me exit out of that. And it shows favorites, and you can go back to your previous screen. So nice. We got that done. Dan, you want to talk about the backstack a little bit?
Hello. All right, so Jeremy mentioned that we get out of your way and you own the backstack, but what does that actually mean? So to show this, I'm gonna go through some example. We have a PM, he's pretty ambitious. We are looking at the competition, so we wanna add some new features to our application. Specifically, we're gonna add another screen. We're gonna call it the profile. We have a bottom navigation bar. But the important thing here is that they want us to do something that we refer to as multiple backstack, which is that case where you have different sections of your app and you can like navigate to them separately. So we're gonna try to implement that in Navigation 3. If we think about the backstack, Jeremy mentioned it was just a list, and it is just a list. It acts like a backstack. So when we navigate forward or deeper, we push into it, but we're adding to the end of the list. And then when you go out, you move back, you could say, or you pop out of the backstack, you're really just removing that last item from the list. So what does that mean to have a multiple backstack? Well, if we look at our app, we can think that we have literally two multiple sections, and we can just have multiple backstack, multiple lists, and we can throw them all into a map. They're pretty efficient and good. The key will be whatever the top level destinations are, and then each of the values will be that backstack. And it acts the same way. We can only show one at a time in our nav display. If we go deeper, it'll just add to that backstack specifically, not the other one. But then we can switch into the profile, and if we go back into our feed and post, we should kind of stay in the same backstack. And that's kind of like what we refer to the multiple backstack. So let's try to code this. I do have a branch somewhere in here to get me started. So we're gonna check it out. In this branch, I already did some little bit of work. Specifically, I started with a, up left. I will check out the branch that I'm on. Okay, top level backs. There we go. I did a little bit of work already, trying to abstract this top level backstack, and also I'll just go through it pretty quickly. I mentioned we want a map. Each map has a key top level route, and it has another backstack in it, right? So if we were to implement this, it's just gonna be a mutable map of, and we're gonna start our destination, and we just create a backstack here. Um, because we do want to know what's the current backstack, we do gotta keep track of that, or what is that top level. So for that, I'll use a mutable state of. Uh, we want to be nice, so this is like an implementation detail. So we do want to only set it within our class. And then what I meant with owning the backstack is that we have a representation of a map of multiple backstack, but we do have to give one backstack to the nav display. So we'll just expose that as a new thing. And this might not be the most efficient thing to do, but it's all right because this is a demo. But the idea here is that this current backstack is what we'll expose to the nav display, but we should be able to modify it however we want. So if we were thinking about RPMs, we want to switch between sections, and for that, I have here a swap to a different top level. This is just technically as easy as switching that current top level route that we have, but we do have a map, so we got to do some more handling. Specifically, if that specific top level key is not there, we do have to add it. So I'll go ahead and do that here. We just again create another list, which is a representation of that backstack. And then if we were thinking about the different operations that we can do, we can add to it and remove to it. So implement these. It's just a matter of getting the current top level backstack, which we keep track of, and we add to it to the end. And very similarly, we sort of get the current top level backstack and also remove that last position because we're trying to pop the backstack, right? And then this is kind of it, but in reality, we are exposing our current backstack. This is the backstack that we'll send to the nav display. So I have this update function here that you'll think it's gonna be weird, but it's for showing purposes. What I want to show here is that we can manage the backstack that we give to the nav display, and I'm just gonna be very dirty here, and I'm just gonna delete everything it has and re-add whatever I think is the current backstack. And again, this comes from our multiple backstack, and it's just a matter of giving whatever we have. So this is like one way to grab that backstack that we get to the nav display and update it however we want. And then I'm just gonna move these olives here. So that should be our top level backstack implementation. We do gotta go to our main activity. We have to change our backstack here. It's gonna be now that new one that we just created, or that abstraction. We are giving it that mirror, but it's really a list that we clear and added. I already updated some other stuff. And then for UI purposes, we do have to create that bottom nav bar. Here we have a list of our different screens, top level screens. There were two that we had already. We had feed, and then the new one that I'm adding is gonna be called profile. I just added there. And then our abstraction helped us with some of the other stuff, specifically what's the currently selected top level destination. Well, we kept track of that in that abstraction layer. So I'll just throw it in here because this is for each of those top level destination. And then clicking on the bottom nav is actually swapping routes. And so if we do this, we should be able to run this and get a bottom nav. Oh, we got a nice. Very demo. So we got a level backstack. Demo time. Woo-hoo. What do we got? I put an X somewhere in there somehow. It happens. Okay, so now we got an app. It has a bottom nav bar. We can go to profile, but the thing about the owning the backstack is that we can sort of do what we want, which is that we can go to a post, we can move to our profile, and then if we go back, we'll be back in that post. So this is that different level of backstack. So that's kind of like owning the backstack. Jeremy has a bit more on scaling.
Okay, so that's all nice. We have a nice simple app. It's 3 screens. It's wonderful, but what we really care about here is scaling. So how might we do this, and why do we care about scaling at all? And the reason we care about scaling is multi-module navigation. So separate out your navigation code into different modules so that you can work on different things at different times. And this helps with exposing and hiding the proper components So this is a really quick overview, but it helps you avoid recompilation crap. And so, for example, if you wanted to work in your feed module and you could recompile that without ever needing to recompile your profile module, and then it helps avoid circular dependency. So I won't get too far into this, but if your profile screen wants to navigate to post and your post wants to navigate to profile, having multiple modules can help you set this up in a way where you don't have to have a circular dependency between these two. But how does that help us in Navigation 3? By using the entry provider DSL and specifically the entry provider builder, we can write our own custom extension functions that allow us to add entries without exposing the internal content of a module, right? So for example, here we have a custom entry and we can add our entry call inside that custom entry, and then for our entry provider, we can just call it. And I'm gonna do that really quick here so we can get to the extremely fun stuff. I have another branch to check out, just in case Danny didn't do everything I wanted him to. And we'll roll back there and force the checkout. Okay, so we'll go to the profile screen. And here we'll write our custom provider here. So it's just a fun. We'll have a generic object that extends any. We'll call it entry provider builder with a T, and then we'll just call it profile entry. Blocks, wow. Nice, and then we can do the same thing we saw before, entry, profile, and then pass it our profile screen. Did I get all that right? Nope, almost. And then if we go to our main activity here, we can replace this with our profile entry. And I did some pre-work to go ahead and get feed entry that takes a backstack the same as the other entry. It was actually top level backstack. And then we also get a post screen. And the fun thing about this post entry is that it only takes the top level backstack. So the thing we had to do before, we had to pass in the post, that's done internally and that's not exposed to us. And you'll notice that all these classes are now internal. So our screens no longer need to be exposed to everybody. And if we run it, still the same, nothing changed. But we made it encapsulated. Danny, you want to talk about DI?
All right, the fun part, dependency injection. So you might be wondering, wait, but this is a Navigation 3 talk. What is it about dependency injection? Well, we did mention it was like enterprise or scalable, our talk, and what's the cornerstone pattern of scaling Android applications? Well, it's dependency injection. If you don't know anything about dependency injection, I'll just have one single sentence here. It's technically a programming design pattern where objects get received instead of making them internally. And it has a bunch of benefits, makes code more modular and more testable. But I won't really go into the dependency injection details. I just want to go, how would you use it with Navigation 3? And hopefully some of the coding will show you the practicality of it. In reality, you can do dependency injection manually, but usually you just use another library. There's a pretty famous one called Dagger. I don't know too much about it. It has Hilt and Anvil with it too. There's something called Coin, Kotlin Inject, and there's something called Metro that is the one that we use here, and I'll show you a little bit. So again, why even use dependency injection with Navigation 3? Well, it does have some connection. Specifically, dependency injection lets you generate a lot of the glue code. And as you just saw, we've been mostly coding some glue code. Specifically, Jeremy was doing those extension functions. You have your nav display, so you got to write that nav entry provider. So dependency injection helps you here because it can help you write that glue code. And then you can pass dependencies into your nav entries and your composable, just like we did with our top level backstack. Technically, there's a scalability part of it. It can enable your teams to work in parallel and in isolation, not stepping each other's toes. In my mind, there's two ways to do dependency injection with Navigation specifically and Navigation 3. First part is kind of like getting your dependencies into your nav entry and your composable. And then the second part is aggregating those nav entries into your nav display and like doing the glue code. So we're gonna start with that first one. We're gonna do this injection with a library called Metro. It's a fancy new library, heavily inspired on Dagger and Anvil. So all the concepts that you'll see here technically apply to other libraries. I just wanted to have fun. It's droidcon New York, of course. All right, so we do have to have a plan. What are we doing? We're gonna create that dependency graph, instantiate it, and just use it on our nav display. So very similarly, I have a branch here because I don't trust Jeremy's work anymore. So I'm gonna force check out and do a clean view here, and boop, boop. And I already got a little bit of a head start by defining an interface, and this is what we'll call our dependency graph. And in Metro, literally, it's an annotation. Metro is a compiler plugin that generates code for you, so very similar to Dagger. So in Dagger, this will be like a component. And what exactly do we want? Well, we want a nav entry provider out of this graph. And you might be wondering, what exactly is that? Well, it's just a formalization of that extension function that Jeremy created. So we're going to type alias it. It is an extension function on entry provider builder of type navkey, and it returns nothing. And so very similar Metro, similar to Dagger. You define your graph, but you also define how those dependencies are created, and we can do this with an app provides method. So here we'll go to provide and nav entry, and we'll create a new function. And right now, all I'm gonna do is just grab exactly the same extension functions that we had already, because those are in their respective modules. So we don't want to do, we don't want to mess up with the compile avoidance. So if we go back to our app graph, I can throw this here. This actually takes a builder, so we're gonna do apply here, builder, and we're gonna move it. Hopefully this should work. Filter there. Yep. Have entry provided. There we go. So you might be seeing here, oh, but we had a top level backstack. How do we get that in? We can consider that a dependency. The cool thing with Metro, similar to Dagger and other, is that the parameters that you define here are things that Metro will give you. So we can just throw in that top level backstack and put it in here. And technically, it'll somehow arrive here. The truth is that we created this in our main activity, so we kind of have to pipe it in. And for that, Metro lets us create a factory interface that we can use, and then we'll wire this soon. So here we do dependency graph. It's another annotation, and it just has one single function. But here's the key thing. We annotate a parameter with app provides, and this basically tells Metro, hey, this top level backstack is something that I can pass around. All right, this is our dependency graph definition. Let's go use it. We gotta go back to our main activity. We're gonna instantiate it right here, slightly after our top level backstack. There's a Metro function here to give it to us. Here we get that factory that we just created. We can call our create function and pass our top level backstack. Lastly, we had our entry provider, and now we want to use our graph, get our nav entry provider, and invoke it. And that's kind of it. And you might be saying, if we compile this and run it, nothing will change, right? And you'll be saying, Daniel, what did you do? You just move a bunch of code around. Well, this doesn't truly show you the ability to inject dependencies. So let's walk through a small example. Imagine now that our PM wants us to have some sort of name in our profile. And so for that, they already gave us a random name factory, and just some random, it'll output 2 names. But the cool thing about this, and with Metro and dependency injection, once we have that infra and the graph, then adding a new dependency and using it is quite simple. We just gotta inject this class, and you do that by annotating the constructor, and then we can go back to our app graph, and then over here, we can have that name factory that we just created. And Metro will give it to us, and we'll be able to sort of pipe it down into our profile. So there's still a little bit of piping to do, but it's way better, I guess, than what we had. So I'll just finish here, go to name, we gotta go to the composable, and ultimately we can use that profile name here. Now, as you can see, I just changed the graph definition, created a new class, injected it, and then I'm able to use it and pipe it down into my profile screen. So this hopefully shows you how you can get an injection into your composable and your nav entry. Right, so that was one part of dependency injection. The second part is what I want to call aggregation. And this really helps with scaling because now it lets you generate all the clue code for all the nav destinations, and your team and your different company can work in different screens at the same time in isolation without stepping each other's toe. The way it kind of works is, imagine you have a big app, you have different screen, different dependencies, and the Gradle dependencies into your app will get aggregated, and basically we call this a multi-binding. It'll create a multi-binding that then it'll automatically create the glue for you. So sometime later, once you have this infra, you add a new screen, then you'll be able to simply show that screen with a lot less boilerplate code. All right, so if we wanted to do this aggregation with Metro, we got to make a plan. We're going to change our app graph. It's going to become a multi-binding, and then we're going to start contributing to it. And contributing is the way of like installing more than one thing. So now I'm going to switch to another branch. I can't blade Jeremy this time, so I'm just switching for my own sake. Gotta roll back. All right, so back into our app graph, sort of where we left off. Now, instead of a single nav provider, we really want to take advantage of that compiler avoidance. So we want to keep our nav providers in their own modules with those internal composable functions. So what we want here is now a set instead of a single nav provider. And what this is kind of trying to tell you is that we're going to be creating multiple screens, and we want to all aggregate them into that single set. Using this now requires me to do a for each here, but it's very similar. We just invoke that extension function. And nav entry provider, it hasn't changed. It is the same type alias. I just move it to the common module so I can use it in other places. Okay, so how do we do the actual aggregation? Well, we can go to our profile screen. We already had the big composable here, and Jeremy had created these extension functions. They're great. They keep my composable internal, but now I want to be able to aggregate them. I want to be able to write something here that will automatically show up on my app graph. And to do that, we're just going to create a class. We're going to call it profile entry provider, and it implements that nav entry provider. This is just, again, that type alias. We implement its function, it gives us a builder, and we just use the same DSL we've been using all this time to get going. And then we can get rid of this extension function. Now, the cool thing here is you might realize, oh, but we had a name there, and this was a dependency that was being passed. Well, now, because we created a class, and this class is gonna get contributed, it becomes part of Metro. And so I can actually also make this an injectable binding that it can be used around. And so I can do dependency injection with it too. So here I'll use something called contributing to set, and this is what gets it into that set that we define. But because this is a class, we can annotate it with an inject constructor, and here we can request that name factory that we had before. But this time it's closer to where it's being used. It's not in that single app provides method, and it keeps things way nicer, right? So name. I took the liberty, and that's it. And this is our multi-binding contribution. This will get aggregated and we'll be able to use it. I did the liberty of doing our other screen. So if we go to feed, you'll see the same thing. We have an entry provider contributing to set. This one's a bit more interesting because it gets that top level backstack as a dependency, but you get the idea. Now to build a new screen, it's a matter of defining more of these nav entry providers. And you can see this being repeated. If I compile, nothing really has changed. A bit boring, but just wait a little bit more. Okay. So we did some aggregation. We were able to define in all these different Gradle modules, these screens that they get added into the nav display sort of automatically. Now we want to do now our PM is asking us to do a new screen. We're gonna call it the setting screen, but if you can imagine, we would have been keep writing those contributions. But what if we could just automate this? As a lazy developer, I don't want to repeat myself. And one pattern I like to use is generating code. So generating code is a great way to solidify patterns within your code base. So let's just go ahead and do that. And for that, I'm going to use something called Kotlin symbol processing, also short for KSP. It'll be super quick, but it is a way to generate some code, and this will help us get to our goal. In essence, when you build an app, you give it your Kotlin sources, and at the end of it, you want to have your app. In the middle of this, there's many things that happen, but between those things, specifically KSP and Kotlin C with Metro happens. So to put it in perspective, what we want to do is we're going to feed some sources into KSP. We're going to make some APIs, but through those APIs, it'll generate new sources. What are those sources? Well, it's those contributions that we will have manually written. Then Kotlin C runs again with Metro. This time we give it our sources and our new generated code, and that should create the app that we want. So if we were to do this, we do need a new API, annotation based. I'm gonna call it nav entry content. It takes the key, which is the nav key, and the scope. This is like very Metro. In Dagger, very similar as scope. And then we're gonna solidify that type alias that we had. Instead of a type alias, now it's gonna be an abstract class. And again, the idea is to generate implementations of these base class that will be a KSP so that they get picked up automatically by Metro. We do have to write a processor. I won't go into too much detail on how to write this processor, but essentially you do have to override a process method. You find all the symbols in it with nav entry content. We're specifically looking for top level functions that are composable. We do some processing, and this type of processing is things like making sure that it's a top level function, annotated with a composable, it has a key. You do the parsing basically of your own API. And then at the end of it, we generate some code, specifically those contributions. We do this with Kotlin Poet, great library for generating Kotlin code. And now we wrote this code, but I'll try to show you the end result just to kind of get an idea, and then we can look at the generated code. But to give you some idea of how powerful it is, I'm gonna check out another branch that I have here where I have some of this already set up. So we're gonna roll back here, pam, 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 boom. So we're back into our app. I didn't do any major changes between those swapping of branches. There is one major change I did, and it was, you remember the top level routes? I decided to do a multi-binding contributions for those, because that way, if we contribute a top level route, then we truly get like a very dynamic app, in the sense that adding a single entry will be able to populate the bottom bar, but also our nav display. So with that in mind, I'm gonna go ahead and do that now. We're gonna, we wanna create a new screen. I already had a package here. So I'm just gonna call it the settings screen, nothing very special. We do have to create a key for it. So I'll just copy paste something that we had already. It does have a different name, so we're gonna call it settings. We do wanna change the icon, I guess. And then the cool thing about this API that we just made is that it just only requires us to write a composable function. Let's call it settings screen. It's gonna be very simple. It's just gonna have a text. This is the settings screen, nothing fancy. We import this. This is a composable function, but then we just made an API called nav entry content, which all it does, it'll generate that implementation of the base nav entry provider. It does need a key. What is that key? The key is the same nav key that we've been using around. And then it does need a scope. And for whatever reason, I use UI scope in this branch, but it is the same idea. And so with this in place, technically, all I need to do is do a build here, and we should be able to see just a new bottom nav entry that got automatically added. Here we go. This is our settings screen. Woohoo! And if you look at the code that I changed, all I did, like if I were to commit this, the only file that I changed was basically the settings screen, right? And so this kind of shows you the power of like being able to generate a little bit of code and then linking it, letting a DI library do the glue code for you. You can imagine if you have multiple screens, many people working on them, but they never having to touch that nav display. If we look a little bit at the generated code, it's as simple as that same pattern that we've been writing. It's a contribution into set, and we are just implementing the interface that we made, and we're using the DSL provider, which gives us the key and so forth. And because we can generate this as much as we want, we can do add inject construction and all of those things that we were doing before, just in a pattern with generated code. And I can show you that a little bit if we go to our feed screen, which is a screen that does require an injection. Nav entry, we annotated with our nav entry content. And this one's interesting because our feed screen requires a top level backstack. Well, if we look at the generated code, it's just following that same pattern that we had before. It is an uninjected class that takes that top level backstack that we know it's already part of the graph, and it just feeds it in as a parameter into the composable. And that's gonna it.
All right, so a quick recap of what we did today. We went through the goals of Navigation 3. We talked about the basic APIs. We talked about owning the backstack, scaling your entry provider, and then we did some injection. This is the QR code if you wanted to get the resources for Navigation 3. This is a recipe. We'll be providing this via recipes. So I know it was a lot. Trying to do dependency injection in the talk is a whole lot, but it is available for you as a resource. And thank you.
Any questions? We have a microphone here. We will take questions. Easy ones only, please.
So previously, the recommendation has been that you pass in lambdas if you want to navigate to a different screen. Is that changing because now we are passing in mutable backstack to each screen, or was that just for demo?
Like I said, it's hello. Like I said, we do recipes now, so we don't require you to do anything, and the guidance it'll change based on your use case. So we were just doing this really quickly for an example because we could inject the backstack. But if you were already taking lambdas, that still works perfectly fine.
All right. All right. Thank you so much for coming. If you don't have any questions, we'll be around anyway if you want to ask us questions. Okay. Thank you.